For this problem, we're going to use either the washer or shell method to find the volume of the solid that is generated when the region in the first quadrant bounded by the graph y equals x squared, y equals 4, and x equals 0, and revolved about the given line. For part A, revolving about the line y equals negative 2. Let's get started with drawing the graph. For y equals x squared, that is the parabola graph, opens up, y equals 4, that is the horizontal line, y equals 4, and x equals 0 is the vertical line at x equals 0, or that is the same as the y-axis. Since we consider in the first quadrant, let's sketch the graph all together in the first quadrant. So parabola y equals x squared, the line y equals 4, and the line x equals 0. We have the region bounded by these three graphs as shaded in the yellow highlighted. I'm gonna label this. This is the graph y equals x squared. This line is y equals 4, and this line is x equals 0. We rotate about y equals negative 2. Let's do the scale. And this is the line y equals negative 2. This problem asks us to do either the washer or the shell method. The region rotate about the line y equals negative 2. Let's start with the slicing technique. We're gonna perform the partition or the slice perpendicular to the axis of revolution, which is the line y equals negative 2. For this bar or this cross section perpendicular to the y equals negative 2, we have the location or the position of this bar at x, where x is bounded by the left end of the region, which is at 0, and the right end is at 2 because the intersection point of the line y equals 4 and y equals x squared occurs at x equals 2, y equals 4, or the other pair 2, 4. As the position in the x direction. So now we can make a list or make a given information as the, the integration will be with respect to x, and the thickness is delta x or dx, the interval of integration is the bound of the x value, which could be any number between 0 and 2. So x is greater than or equal to 0, less than or equal to 2. To do the slicing technique, when we rotate about the line y equals negative 2, it will form the washer. I'm gonna make a note. So this is the washer. As we are working on the washer problem, what we're gonna need, we will need inner and outer radius. To consider the inner or the outer radius, we look at the distance from the axis of revolution to the curves, to the closest curve and the furthermost curve. For the closest one would be the parabola graph if we refer to the bar that we just drew. So this would be the inner radius. Then we make a note on the side here. The inner radius is the measurement from the closest curve to the axis of revolution. The closest curve is on the top of the axis of revolution, so we can set it up as x squared minus negative 2 or x squared plus 2. And then the outer radius would be the measurement from the furthermost graph all the way to the axis of revolution. I'm going to write this as a R out. So the outer radius, the top graph is y equals 4. The bottom graph, which is the axis of revolution, or negative 2. Then we get the outer radius as the value 6. Now we get everything we needed. Then we're going to set up the integration to find the volume. So we get the volume equals the integral from 0 to 2. The washer is from the area of the outer circle. I'm going to set it up like the pi r of the outer radius minus pi multiplied by the inner radius squared, and then multiplied by the thickness as the general setup way. And when you replace the value, the outer radius, which is 6, so going to be 6 squared. I'm going to put a note up here for the quick reference. So this is the 6 or 6 squared, the r inner, which is the quantity x squared plus 2, and then we're going to square it. And then the next slide, I'm going to do as a quick computation, 6 squared, which is 36, minus the quantity x squared squared, that's x to the 4th, minus 4 times x to the 2nd, and then minus 4 become, plus 4 become minus 4. And then with respect to x, and the most simplified integrand would be pi multiplied by the integral from 0 to 2, quantity 32 minus x to the 4th minus 4x to the 2nd with respect to x. And after you do the procedure to find the antiderivative and replace with the upper and lower limit, the answer should come out as 704 pi divided by 15 as the value of the volume by using the slicing technique, that is the washer technique. And then for the second way that we can do by using the shell method, I'm going to add another slide and then redraw the graph from what we have. We have the parabola, the line y equals 4, the line x equals 0, and the region bounded by this curve. We rotate about the line y equals negative 2, the axis of revolution, which is this line. For the shell technique, I'm going to put here, right now we're going to do the shell method. And the shell method, the cross section will be parallel to the axis of revolution. We're going to perform like one bar parallel to the axis of revolution. And this will show us that the position of the bar lined on the y axis. I'm sorry, so this can be y. Then we can make a note to ourselves. The problem gonna be with respect to y. The following part, the thickness of the bar gonna be delta y or dy. And again, we have to label the intersection point of these graphs, which at x equals 2, y equals 4. And this is the line y equals 4, and this is the curve y equals x squared. And since we know that it's about with respect to y, the function must be rewritten in terms of y or x in terms of y. So then the y equals x squared, it becomes in the form of x equals square root y. And the right function here, which is the line x equals 0. Since we know that it's with respect to y, we already got the thickness as a dy. The following part gonna be the interval of integration. As you pretend like you are moving the bar within the region, you move it along the y direction or up and down. So the lowest y gonna be 0, the highest y gonna be 4. Interval of integration is y greater than or equal to 0, less than or equal to 4. And when you perform the rotation, it's gonna be the shell that wrapping around the axis of revolution. Next, we're gonna need the radius of the shell and the height of the shell. I'm gonna put the note here. It's gonna need. And how to find the radius? The radius is measured from the axis of revolution to the position of the bar. From the figure, we can see that the radius is the measurement from the top part to the bottom part. The top would be the position y minus the bottom part, which that would be the axis of revolution or -2. So I'm going to put a note here. So y is the position of the bar and -2 is the axis of revolution. Then the radius is simplified into the form y plus 2. And the next, we're going to find the height of the bar based on the same bar. The height would be the measurement from the right end to the left end. So the right end would be the curve and the left end would be the y-axis or the line x equals 0. So the height equals, I use notation h, so I'm going to keep as a h for the height equals the right function, which is square root y, minus the left function, which is 0, or just square root y. So then we can set the integration using the shell method on the side here. So the volume by shell is the integral from the lower limit to the upper limit, the circumference, which is 2 times pi times radius, and multiply by the height, and multiply by the thickness. 2 pi is the coefficient. Integral from 0 to 4. The radius is the quantity y plus 2. The height is square root y. The thickness is dy. And next, we just simplify by expanding the product. Square root y times y. I'm going to put the note on the side. So note that y multiplied by square root y is y times y to the 1/2 or y to the power 3 over 2. So the first term is y to the power 3 over 2. The second term is 2 times y to the 1/2. And then do it with respect to y. The antiderivative would be y to the 5 over 2 multiplied by 2 over 5, which is from multiplying by the reciprocal, plus 2 times y to the 3/2 divided by 2 over 3 and becomes 6 over 2 times 2 over 3. That becomes 4 over 3, I'm sorry. And y to the power 3 over 2. Evaluate from, let me take care of the integral sign. It should not be there after we find the antiderivative. And then integrate from y equals 0 to y equals 4. the calculation or put in the calculator, take care of the algebra, we should get the same answer as 704 multiplied by pi divided by 15.